Our goal is to calculate the Laplace of function. In this case, our function is piecewise defined function. Between 0 and 1, the y value of the function is -1. And as you can see, 1 to positive infinity, the y value of the function is equal to 1. And this is the definition of the Laplace transformation of a function like f of t, which is improper integral. So let us begin. We're going to define two integrals. The Laplace of this function is equal to the very first integral is, let me change the color, is the integral 0 to 1 of e to power negative st times the function which is -1 dt plus the second integral from 1 to positive infinity of e to power negative st times 1 d of t. So we're basically going back to elementary calculus and do the computations here. The Laplace is equal to, here you can basically take the negative sign and use it in the method of u sub. So let us remember that for the first integral, let u be negative st, du is equal to negative s dt. So basically you're going to multiply this guy by 1 over s times s. So you're going to use du. So the first integral can be written as 1 over s times the integral of e to power u du. I'm going to do the same thing for the second integral. Here, let u be negative st and du is negative s dt. So you're just going to multiply this by, let me type it here, a -1 and -1 over s, and you can just multiply s here. So this guy can be written as -1 over s times the integral of e to power u and du. As easy as that. So now you're going to calculate these integrals, which are easy to work with. Here you have 1 over s e to power u, but your first u is negative st, and then your t is bounded between 0 and 1 minus 1 over s of e to power u, and your u is negative st, and your t ranges between 1 to infinity. Very good. So let us continue. This guy can be written as 1 over s. And then you can write this with negative exponent or positive exponent, either is fine. 1 divided by e to power st, t ranges between 0 and 1, minus 1 over s. Sometimes it's easier for students to see this with positive exponent. And please note that here we assume s is positive. Very good. So let's continue. Now just do the regular substitution. Here you have 1 over s times 1 divided by e to power s minus 1 e to power 0. And here you have minus 1 over s times, here you plug in infinity, 1 divided by e to power infinity minus 1 divided by e to power s. So as you all remember, e to power infinity is 1 over infinity, which gives you 0. So we can get rid of this quantity here. This guy is equal to 1 over s times 1 over e to the s minus 1 over 1, which is 1, minus 1 over s times, you end up with negative and negative. So later on we can change this to positive 1 over e to power s. So as you can see, you can simplify this because you have like terms. This is 1 over s times 1 divided by e to power s minus 1 over s. Let me use the same color to avoid any confusion. Plus 1 over s times 1 over e to power s. So as you can see, these two are like terms. You can combine these two, and this guy is equal to e to power negative s multiplied by 2, so 2 e to power negative s divided by s minus 1 over s. And this is our final answer. So the Laplace transformation of this piecewise defined function, this is a piecewise defined function. You have two pieces for this function. We can also visualize this function here as well. So for visualization, between 0 and 1, the function is negative 1. So between 0 and 1, the function is negative 1. So assume it is here. And then when t is more than 1, here you have 1. The function is 1. So 1 to infinity, the function continues. So the Laplace transformation of this piecewise defined function after applying the definition of Laplace method is nothing but 2 e to power negative s divided by s minus 1 over s.